Thanks everyone. And I'm going to talk to you today about path to open source database as a service with Kubernetes. I only have 25 minutes, so we'll go to move fast here. I'm not sure about your involvement with open source, but I got involved with open source sometime in the late 90s. And at that time, open source or experience of using open source with us was very different than it is right now, right? You would have to download resources, maybe patch them to run well on your specific Linux flavor, patch them, and so on and so forth. And from that point on, I really saw a lot of improvement in that user experience, right? We got RGZip packages and install, then Debian and npm packages, repositories. Now we have Docker and Snap things, to avoid taking care of dependencies altogether. And if you really look at that, is what we have is trend, what things are being easier and easier for people to get engaged with open source, right? And the barrier to entry is reduced. And I would argue what if you look at the modern open source, and if you look at the developer and their toolbox, probably wouldn't be able to build that from scratch, right? And you don't really need to, right? I think very few of people are capable compiling their, Linux distribution, right, or whatever, right? We really got used to things being very easy and convenient for us. And that is actually the good thing, because that allows us to use more complicated, often in this case, more valuable software, which allows us to be more efficient at building better apps faster. All right, and that really allows more people to be involved with open source as developers or as a software users. Now, I think, though, that also has a dark side, right, with seductive convenience, because the next level of simplification for a lot of software, it comes with vendor lock-in in the cloud, right? Because as the next step, if you want to use software either more conveniently, then you have to sort of lock in and use proprietary API, proprietary ways to use and deploy that open source. And then it's really indistinguishable from proprietary software. When you speak about the databases itself, we call that database as a service, right? Or DBaaS. And really this way of deploying database in the cloud, it really has a lot of benefits. It really removes a lot of toil or kind of a repetitive, boring work, right? Which DBAs would have to do, and let them focus on more of the application related things, right? Like database as a service will manage availability for you, will do like security patching, ensure backups have done. It will ensure you're not doing, like some stupid performance mistakes, like running with defaults, and provide some ways for you to easily scale, right? Like we're changing the instance size. So this is all the great stuff, but as I mentioned, currently that really comes with proprietary software. Even though it has some open source database inside, it creates a lot of lock-in, same as and other limitations, right, as a proprietary software does. So wouldn't it be great if you could get this fantastic public cloud-like database as simplicity, but as an open source solution? And I have a bad news for you in this regard. What we are not there yet, at least when it comes to the database as a service. right? But if there's bad news, there are also good news is there are trends in the industry which are developing and allowing us to create such a solution in the future. And specifically, I believe that Kubernetes is a very important foundational piece in this case. Right, probably most of you know what a Kubernetes is, but for those who don't, I will mention what Kubernetes is like your operating system, but for a cluster, not for individual hosts. And it has a lot of momentum in the community and in business. And the fact that made it to be universally supported in public, private, hybrid cloud. Right, here are just some of examples of the vendors which support Kubernetes, right? You can see the big cloud hyperscalers are here, as well as some more smaller clouds providers like Linode, OpenShift from Red Hat. VMware is also, jump on Kubernetes bandwagon. So it really is universal. You can run Kubernetes in the clouds, on your laptop, on the edge, anywhere. Now, one thing about Kubernetes, though, is it was always kind of not designed for stateful application, right? It started for stateless applications like your app server, right? And the database was supposed to live somewhere else, right? But well, over time, right, to figure out, well, we need a good way for running the databases at scale in the cloud as well. And it was kind of natural to adapt to Kubernetes for that instead of building something else from scratch. Now, even if you look at some Kubernetes expert, right, in this case, Kelsey Hightower, you can see even, barely over a year ago, it was often, questioned to what extent you can or should run stateful application Kubernetes. And databases are obviously the very definition of a stateful application, because that is where you should store your state, so other things can be stateful, right? So over the last few years, Kubernetes really made a lot of steps towards supporting stateful applications yet, right? We have a support for something called stateful sets, right, which are really allow us to deploy, which is designed to deploy stateful applications. We have a concept of a persistent volumes. That is another very important requirement, because the database data will probably live much longer than Kubernetes pods. And we also have an operator framework, which is an essential piece to automate deployment and the whole life cycle of a databases, right? Because unlike many more simple stateless applications, you can just, deploy the application, right, and have a load balancer, pick up, and that's it, right? All the database operations, deployments, rolling upgrades and other have a lot of moving parts and need to be really done in very particular order with extreme care to avoid data corruption or extended downtime. Now, it is not just what Kubernetes has those features, but we also have a number of solutions right now which are built by the Kubernetes, right, and running at scale of thousands and tens of thousands of instances powered by Kubernetes. Cockroach Cloud, InfluxDB Cloud, PlanetScale, and then a few others like MariaDB, DataStax. They are all running on a Kubernetes backend right now, right? And that means what it is ready for prime time right now, not just for playing by developers. Okay, so what are we doing in this respect from Percona side? Well, first, we have released the operators for MongoDB and for Percona XtraDB cluster, right, which is basically for MySQL, right? Both of them are, generally available, right? We have folks running them for some very important workloads, and those are completely open source, right? There are no tie-ins to some commercial software some other folks do, right, or something else. So in this example, I will, in this presentation, in my sort of example part, I will focus on Percona XtraDB cluster operator, right? So what is Percona XtraDB cluster? This is the MySQL compatible database, right? It's uh, based on MySQL. We just can't, call it that for a trademark reason. It provides you like a strong havability where you have a cluster where every node can go down without no loss of your data or transactions. You can configure that so you can read from any node, right, to any node. And also, if you can say, well, I don't want to deploy a cluster, I'm, just developer, you can just deploy a single node, and in this case, that will be especially indistinguishable from your you're deploying the MySQL. All right. If you think about Percona approach here to database as a service and Kubernetes, we are kind of targeting two kind of users. The first is the direct users of Kubernetes operators, right, who are very familiar operating with Kubernetes and want to have a best way to run the database inside it, right? They're familiar with working with YAML files, right, and other other jazz. The other kind of user we also very much focus about is saying, hey, we want a service which happens to run Kubernetes on the backend. Something similar to what the XtraDB or InfluxDB are doing, but something you can, which essentially gives you their, some simple way to provision the database without understanding Kubernetes internals a lot, right? Something similar to what those folks at XtraDB or InfluxDB are doing, right? With that, what you have also provided is this experimental tool, which we call Percona Database as a Service CLI, which really allows us to manage the databases very simply. And what we're going to do here is to walk through what experience you would have, right, and how simple or complicated, depending on you, would be to deploy the database in the Google Kubernetes engine. Why I pick Google Kubernetes engine here? Because Google Cloud, of course, is universally accessible in majority of the countries, and it has a very great implementation of Kubernetes across major clouds, right? Not a surprise, right? Because Google was, the founders of Kubernetes projects. It also has rather easy to use command line tool, which is convenient in this case. Okay, so what do we need to have our database cluster deployed in Kubernetes? Well, we need kubectl, Google Cloud SDK, and Percona Database as a Service CLI. How to get them? Well, to install kubectl, you just can connect to the packages, right, and install the kubectl. As mentioned here, for Google SDK, you do pretty much similar steps, right? So do a repository and then install a package. There are other ways to install it, but if I using the plain Linux, I always like to connect to repository, because that's not just gives you the one-time install, but you also can upgrade packages easily, which I think is especially important this time and day. There is so many security holes being constantly discovered and a company is being really attacked for ransom, right, or whatever. Percona database as a service CLI works a similar way. In this case, there's a kind of extra step, right, to manage Percona repositories, right? We provide a whole bunch of different products, right, and sometimes they may conflict with each other, right, for some historical reasons. So we provide you different different repositories, but also kind of one tool to manage all of them. To setting things up, well, you obviously need to authenticate, right, and kind of to connect your laptop, developer workstation, right, where we used to operate the Google Cloud in the cloud, right, with Google Auth login and your browser. Then in a Google Cloud, you will have a concept of the projects, right? You can have multiple projects, environments, and so on and so forth, and you need to set the project in which you are going to be operating. I think they're doing this kind of nice thing of coming up with this, a random name, n number, which is harder to mistype compared to just number, when one digit error may be ending up in completely different location. The next step, we are creating a cluster. In this case of Kubernetes, at least we need a minimum of 3 nodes to deploy Percona XtraDB cluster. Then we have to create an admin role, in this case, for us to manage that cluster. And then we have to kind of create another project, or it's called namespace in this case, inside the Kubernetes cluster, in which space where database will be created, right? So we have Google project, which can have one or many of Kubernetes clusters, and in which each Kubernetes cluster you may have a number of namespaces, right? And then as you do that, you then set the namespace which will be used by the deployment, right? This is kind of a little bit complicated, right? I mean, you probably need to do those steps, but the great thing is you need to do that only once. And as you've done that, you can start provisioning a database very simply with a single command, pretty much, right? Like in this case, we're just saying we want to create the MySQL database and call it example. It will, just do whatever is needed, and you will get a database cluster deployed on your Kubernetes and the credentials printed out, right? So you can use it. If you want to connect that from your laptop, is by default, we do not expose, for security standpoint, the MySQL right outside of a Kubernetes cluster. So if you want to connect to that, you may want to use kubectl for this port forward, right? The first command will create a port forwarding and start in the background, and then you can use your favorite client, MySQL, or like GUI clients you like to connect to this system as it would be localhost using the password provided. Okay, well, if you would say that's all good, but I actually need to access my database, which is running Kubernetes cluster, from somewhere else without this kind of trickery, all right, in some reliable way. And you can do it as well. You can specify the service type equals load balancer. In this case, we'll get a resource endpoint, which will be IP, right? And that will be will be managed for you, and you can now connect to that IP using a password. If you want to use this for automation, say, look, I want to specify my own password instead of just getting secure random password. You can do it too by passing the password argument in just for security purposes. We did not want to create the instances by default with some, standard password, right? That is not practice. So if you don't specify password, you get a random password created for you. If you specify password, well, you can do that too. Well, and finally, as I mentioned at start, if you do not want to deploy the cluster, you can also deploy their single node. We kind of intentionally made it a little bit harder at this point, right? Because in the Kubernetes operator itself, we want to prevent the user from shooting himself in the foot and, for example, deploying single node cluster, right, or scaling down cluster to having only one node and then losing that node and saying, oh my gosh, what happened, right? Well, that's supposed to be support highly available cluster. So by default, the operator will require running at least 3 nodes, right? But if you want to deploy a single node, you have to say first what you are allowing unsafe configuration, right? And then you specify the cluster size in this case. And if you do that, then, well, you don't need to have a proxy SQL anymore, right? Because there is no point of load balancing a single node. Now, one thing I would notice here is what, while this is all good, their Kubernetes operator and the command line utility we provide, we do not think that that's enough to really get the database, full database as a service experience, right? And that is just the first step. As Percona, we are working on Percona Enterprise platform, which provides that kind of full cycle, all right, for database as service work, right, and with comparable. With our goal is experience comparable to something like Amazon RDS or Aurora, you name it. We call it Percona Enterprise Platform, but don't be mistaken. We call it Enterprise not because it's going to be proprietary as many enterprise versions of so-called open source software, but it is what it is for focusing, has all the features to be used by the enterprises while we're still keeping it open source as the rest of Percona software. As a summary, I think what Percona database service can get you, a taste of some of a database as service-like experience of Kubernetes, and we are continuing to work, on the features to extend usability, and we very much want to invite you to give it a try, provide us feedback, or participate in development and submit a pull request, right? And let me mention and with those 3 simple thoughts. One is I believe database as a service has won, right? Because it really provides unparalleled convenience of using a database. And let's face it, we are so all suckers for convenience. The second is what a software vendor lock-in absolutely sucks, and you can should avoid it when you can. And then, as in the many other software areas before that, the open source is coming to the rescue. And what is a wonderful thing about that is what it is opportunity for all of that to participate in making open source database as a service reality. Thank you. That's all I have, and I'll be happy to take some questions if there's any.